Okay, our last part of this biotechnology unit is on the Human Genome Project and um, genetic modification that could potentially one day apply to humans. So, humans were not the first organisms to have their genes completely mapped out. So, what that means is that the whole entire genome is known. So, the genome, not a gnome, there's an E in there, are all of the genes on all of your chromosomes. So that was first done in mice. So the Human Genome Project we see was an international effort to map out the location of all of the genes of a human. So that's been done. And it was, like I said, an international effort, and it took a few years to get that accomplished. But now that that's known, it's about how do you go forward with that? What can be done with that information? And a lot of that has to do with improvement of our health, the extension of life, the improvement of the quality of life for people. So that Human Genome Project, initiated in 1990. When I was at Emory, I was a Lyceum, and there was uh, a man there who was a part of this Human Genome Project, but his talk was way up in the clouds, complicated, and at the time for me was completely uninteresting. But hey, he did a big thing. Okay, the technologies and principles behind the Human Genome Project has expanded to the following applications. So what can we do with it? My mind goes straight to humans and gene therapy and what can be done to improve our life. Other things, energy sources, environmental applications, um, thinking about some cities and their sidewalks, they have certain types of bacteria in the concrete that can help to absorb the oil, and that's how they can treat oil spills. Well, what if you could expand that beyond those bacteria? Risk assessment of certain diseases. So that's being done with other organisms. And I mentioned before the gene knockout with the mice, to see what can happen with the human. And again, comparison of those base pairs and the genes that we can use in that gel electrophoresis and that DNA map that we can get. So it's something we've already seen. Bioarchaeology, anthropology, evolution, human migration. So if you've ever watched Bones, the anthropologist. So one of the things that I think is interesting, kind of goes hand in hand with this DNA forensics and identification, is that genetic genealogy. Um, some people don't like to use that 23andMe because they feel like you're going to have like a database of all of your DNA. And I'm like, well, I don't plan on committing any crimes. And if I do know of anyone who's related to me and they have committed a crime, I don't want them to get away with it. So I'm definitely for sure sharing my DNA. But this is something that's coming to the forefront of late. And could and will probably become something that you'll see more of in your lifetime. And then, of course, some of the practical things is what can we do to improve not just my life, but everybody's life with uses in agriculture, livestock breeding, and bioprocessing. So expanding beyond us. Okay, so there is a little video here talking about gene therapy, one of my favorite topics when it comes to genetic modification. So I will catch you on the other side of this video, and make sure you pay attention to the screen because there's a really important little picture I put on here, the difference between a gene and DNA. So the DNA, we could see there's that whole entire double helix, but we can look at that whole entire double helix and we can separate it into these different segments that code for a particular protein. So we can separate them into these individual gene, sorry, I got distracted. we can separate them into these individual genetic sentences, and we know how to do that with the codons and use the chart to determine the amino acids. And we'll deal more with genes in our next section of genetics on heredity, inheritance.